So good morning everybody. This is Nandini Physics Academy, Nandini Physics tutorial for IIT JAM, GATE and CSR Net. So today I'll start lecture 12, atomic and molecular spectroscopy. Okay. So in previous section, that means in lecture 11 I explained the spectral term, that is nothing but term shift delta T is equal to R alpha square Z power 4 divided by n cube L into L plus 1. So in previous lecture I explained these things. Finally I stop here. So that is called delta T proportional to Z power 4. So the term shift delta T is directly proportional to atomic number, 4th power of atomic number. So we will get this equation in previous class. Okay. So see the small CSR problem based on this term shift. See here they are given if doublet separation of first excited state, if the doublet separation of first excited state, that doublet separation is given by 2. This is called principal quantum number n. Okay. So n here 2. So 2 power 3 by 2 multiplicity 2 and 2 power 3 by 2 2 power p by 1 by 2. P into 1 by 2. So this is the angular momentum J and these are the P, same P values, and L is equal to 1 in this case, and this is the multiplicity. So if if helium plus atom is 5.84 centimeters, find the corresponding separation of hydrogen atom. By using this formula we can find out the separation, because he was asking the separation. Okay. So for that purpose I will solve this problem. This problem is given in a previous paper, that is called CSR problem. So what is your answer? Okay. So simply find out by using this transaction. Okay. So first of all I consider the same equation delta T is equal to Z power 4. So that is nothing but hydrogen. So right now here given helium and hydrogen. So you will take the ratio, okay, delta T hydrogen. So delta T hydrogen divided by delta T helium. Okay. So here already given there is a condition, that is nothing but delta T is equal to proportional to Z power 4. So this is the relation. Now I will take the term shift delta for hydrogen atom and the delta T for helium atom. So that is nothing but it is equal to Z power 4, because it is a directly proportional. So the hydrogen atom and helium atom, so directly proportional. So therefore hydrogen atom of 4 divided by helium atom of 4. So this is the formula. So delta T is H. So how I will write this equation means delta T hydrogen is nothing but Z power hydrogen 4 times, and delta T helium is nothing but Z helium 4 times. Okay. And what is the atomic number Z for hydrogen atom? So that is nothing but 1. So for helium that is nothing but 4. Okay. So that is helium is nothing but 2 power 4 times, because 2 helium is 2 and hydrogen is 1. So atomic number for hydrogen is equal to 1, atomic number for helium is equal to 2. So therefore substitute delta TH divided by delta TH is equal to 1 power 4 by 2 power 4. So this is called 1 by 2 power 4 means 2 2s are 4, 4 2s are 8, 16. Okay. So therefore they are given delta He plus is shift 5.84. So delta TH divided by they are given 5.84 centimeter inverse is equal to 1 by 16. So simply substitute delta TH is equal to hydrogen atom shift is 5.84 centimeter inverse divided by 16. So this value is approximately equal to 0.365 centimeter inverse. So this is the problem. How you will find out by using any type of such transactions. So this is a problem. So those type of problems is also possible to given in CSR and JAM, something GATE exams. So in anywhere these are the very important notation. So this based on this formula you can give this such type of questions. They are framed such type of questions. So this is the concept. Okay. So next concept is energy shift in terms of alkali spectrum. So for suppose he consider alkali spectrum, what is the energy shift? So in alkali spectrum I want to find out the energy shift in alkali spectrum. See, okay, so this is the problem. I erase this problem. Once again I write what is the energy shift in hydrogen atom by fine structure. Okay. So using fine structure concept, what is the energy EL? Energy shift delta EL is equal to, so A by 2 times of J into J plus 1 minus L into L plus 1 minus S into S plus 1. So this is the where A is equal to RCH alpha square divided by N cube L into N cube. So simply I write N cube L into L plus 1 L plus half. Okay, so this is the R value according to fine structure, according to spin orbit interaction. So this is the term which is arrives from spin orbit interaction. So finally we prove this equation in last session. Delta E Ls is equal to A by 2 times J into J plus 1 minus L into L plus 1 minus S into S plus 1. So this is A where A is equal to RCH alpha square and N cube L into L plus 1 into L plus 1 by 2. So for suppose according to spin orbit interaction, this is the P state. This P state is right now split it into two ways, that is called J is equal to L plus half condition and J is equal to L minus half. Okay. So there is a shift between these two another, that shift is nothing but delta E. Okay. So once again I substitute these two equations. In previous class I already explained, in substitute J in term L plus half and one first case, and second case in terms of J into L minus 1. So I will get in this case what is our value. The value is came from delta E is equal to, see, nothing but E is equal to in this case. So these are the single states, actually energy E and E. So therefore E initial state, E final state. Okay. So energy, like, so do not write delta E because it is a single split. So you will substitute for single one. Okay. So therefore this value is come from A by 2 into L, this value. Using this substitute this value in terms of J. So substitute J is L plus 2 in this equation, you will get A by 2 L. If you substitute J is equal to L minus of 1 by 2, you will get minus A by L plus 1 only. Okay. So you will get this equation from, so A by 2 only. Okay. So you will get these equations, because directly I will put here A by 2 L minus A by 2. In previous lecture, you listen previous lecture 11, in that I explain all these things, okay, how they are derived. Okay. So what is the energy shift right now? Delta E is equal to, from L to S is equal to, simply you will add these two equations. So E initial, okay, initial minus E final. So you will get delta E initial is A by 2 L minus of minus A by 2 L plus 1. So you will get, see, delta E is equal to E Ls is equal to, see, simply take A by 2 common, both sides A by 2 into common. So therefore L plus 1. So you will get this equation. This is called A by 2 into 2L plus 1. So finally you will get delta E is equal to A times of L plus 1 by 2. So simply multiply, divided by both sides 2. Okay, this 2 will be cancelled, 1 plus 2. So you will get energy shift between the two states is delta is equal to A into L plus 1 by 2. So we will get this equation. The splitting energy between these two states are delta E A plus T. So I think one previous CSR problem was given. What is the energy shift? What is the energy shift delta E, okay, in P state, I think they are asking in P state, okay. Simply he was asking what is the energy shift delta E for P state. So how you will find out P state is nothing but, see, this is the P state is splitting into two ways. So this is the splitting, okay. So this is J is equal to L plus half, J is equal to L minus half. So according to spin orbit interaction, P state will be splitting into two ways, that is called J is equal to L minus half into J is equal to L plus. For P state, what is L value? 1 and S value is 1 by 2, okay. So S value is 1 by 2. What is the J value? J is nothing but 1 plus 1 by 2 to 1 minus 1 by 2. So that is nothing but 2 plus 1, 3 by 2, and this is 1 by 2. So you will get 3 by 2, 1 by 2, okay. So therefore the values are here. If J is equal to L plus minus 1, so you will get the spectrum splitting into two ways, P state. For L is equal to 1, S is equal to 1 by 2, you will get, so what is the multiplicity? Multiplicity 2 into S, nothing, 1 by 2 plus 1, that is called 2 will be cancelled, splitting multiplicity 2, and the state is represented P, okay, and J value from 3 by 2 upstate and 1 by 2 downstate. So 2P 1 by 2, 2P 3 by 2, okay. So therefore energy shift between these two states we will represent. This is the energy shift delta E. So that formula delta E is equal to A times of L plus C from this equation formula A by 2. So delta E is equal to A times of 1 by 2 means L is equal to 1 plus 1 by 2. You will get the term shift between the energy shift between these two levels are nothing but A into, see, 1 by 2 to plus 1 by 2, 3 by 2. So you will get delta E is equal to 3A by 2. So this is the term shift between P state by using this equation. So what is the energy shift delta E in P state? Similarly, you can do in L is equal to 2 for D state also. So in D state, you will get, this is a 5A by 2 in D state. Why? Because if you take D state, so this is the D state, okay. In D state, see, actually L is equal to 2 for D state and S is equal to 1 by 2 for D state, okay. L is equal to 2. So J value starts from 2 plus 1 by 2 to 2 minus 1 by 2. So you will get 2 plus 2, 4, 2 into 2, 4 plus 5 by 2, 2 minus 2, 4 minus 2, 3 by 2. You will get, this is 2P 3 by 2 to 2P 5 by 2. So in between we have energy shift, that is called delta E. So using this formula, delta E is equal to A times of L plus 1 by 2. So therefore A into what is L value? 2 plus 1 by 2. So you will get, this is called 5A by 2. So energy shift delta E in D state is 5 by 2, 5A divided by 2. So this is this type of problems will be came in CSR and JAST and NET, GATE, all these things. So these are very important formula. So please remember the energy shift between P state and D state, otherwise F state. They are asking in which state, no problem. If they are given A values also, what is the A value? A is nothing but RCH alpha square by Z power 4 into N into, see, N into L into L plus 1 into L plus half. So you will simply get this value, term value. They are asking term value. For the shift term value, they are asking T is equal to delta E by HC is equal to R alpha square Z power 4 something, N cube into N cube, L into L plus 1, L plus half. So they are asking like that. The value of R comma alpha square is nothing but 5.84 centimeters. So simply substitute 5.84 divided by, say, you will get L value from P state and you will get N value from free state. So if both are principal quantum number, take N is equal to 1 for both cases. So simply you will get this answer by term shift also. You can easily find out by using this procedure. Okay. So these are the very important. So now we will move to relativistic correction, okay, of this equation. So you will get this equation. I want to find out the relativistic correction of this equation. So in last session I stopped this equation of delta T, Okay, so delta T, after then I am not conducting. So right now I want to find out the same energy shift in case of relativistic by using first order perturbation theory. So I want to find out the correction in the case of relativistic atoms. Okay, that is called, if you consider an alkali spectrum, so in alkali spectrum it is not look like a hydrogen spectrum. So if it is in non-relativistic case, there is no change in energy, but in case of relativistic system there may be a change in energy. So I want to find out the changing energy in terms of relativistic theory, okay, by using alkali spectrum. So in previous class I will get this equation. See which equation I will get, I will write there here. See, in previous session I stopped this question. See, this is I will get delta T. So delta T is equal to, what is the term shift, R alpha square z power 4 by 2 n cube L into L plus half. Okay, so I think this equation I will get n plus half, not n plus L plus 1. Okay, 2 n cube L into L plus 1. So from this equation in previous session I will explain up to here. Okay, so right now I consider alkali spectrum, so in relativistic notation. So if you find out the fine structure for alkali spectrum, okay, find out fine structure for alkali spectrum, okay, alkali spectrum. So this is the question. See, if you consider this is an atom, okay, so Ze is a nucleus part, the electron revolve around this nucleus, okay, with a velocity v. So what is the velocity formula Vn for this electron of nucleus? This is the nucleus part and the electron which is revolving around this nucleus with a velocity, with a sufficient velocity Vn. That velocity is 2.2 into 10 power 6 Z by n square into meter per second. Okay, if you take the proton number Z is equal to 10 for alkali spectrum, so you will get velocity Vn is equal to, see, 10 power 6 into 10 power 1. So that is called 10 power 7 meter per second. So actually this velocity is approximately equal to velocity of light. So alkali spectrum is visible and the spectrum is like its velocity of that spectrum is almost all equivalent to light velocity. Okay, so alkali spectrums are visible region, alkali spectrums are developed in visible region. So that velocity of electron is approximately equal to velocity of light. So therefore if these electrons are treated as in relativistic spectrum, okay, so this theoretically considered as relativistic particle. Okay, so this electron is considered right now to be a relativistic particle. So according to relativistic particle theory, the energy will be changed. Okay, why? Because in non-relativistic case, if you consider in non-relativistic case, what is the energy of the non-relativistic state? So for suppose kinetic energy K, total energy in non-relativistic is equal to kinetic energy in non-relativistic plus potential energy. So this is the formula for non-relativistic case. So if you consider in relativistic case, ER is equal to kinetic energy for relativistic plus potential energy. But if this is a kinetic energy of the particle, whatever it may be, in non-relativistic there is no problem. But in relativistic case, because here we are consider electron is treated as relativistic particle, relativistic particle. So electron treated as relativistic particle. So electron treated as relativistic particle means, see, this means this electron, relativistic electron, is revolving around this nucleus. So that's why it creates some energy. So that energy is nothing but alkali spectra energy, that energy is nothing but total energy. In relativistic case, ER is equal to kinetic relativistic energy KER plus potential energy. Okay. So right now, if you consider electron is treated as a relativistic energy, then what is the kinetic energy of electron? That kinetic energy, total energy of the electron is nothing but total energy in case of relativistic theory is root over p square c square plus m naught square c power 4. So this is the total energy. So therefore, this energy can be split into capital E minus E naught. So this is called rest mass energy. Okay. So we are adding rest mass energy in relativistic case. So therefore, total energy is equal to, in relativistic energy is equal to total energy minus rest mass energy plus potential energy. So this is about theory. Okay. So right now we substitute E is equal to root over p square c square plus m naught c square c power 4, because this is the relativistic case total energy. So this is the relativistic energy and this is the energy in which the electron treated as a relativistic particle. So therefore, E is equal to, what is the E value? Root over p square c square plus m naught square c power 4 minus, see what is E naught value? E naught is equal to rest mass energy, that is called mass m naught square c square. So therefore, this is called m naught c square plus potential energy. So what is the potential energy? Simply take potential energy is V only, okay, because potential energy is take V, and the relativistic kinetic energy ER is equal to E minus E naught. So using this formula, I can derive all these things. Okay. So this is the equation, relativistic energy, total energy of this alkali spectrum. So total energy of the alkali spectrum is called nothing but energy minus E naught. This is called relativistic energy. Okay, and minus rest mass energy plus kinetic energy. Okay. So the total kinetic energy is nothing but E minus E naught right now. So I want to find out the total energy in relativistic case, and relativistic case energy kinetic energy is nothing but, see here I will write kinetic energy in case of relativistic theory represented by E minus E naught. So this is the total energy right now. So I want to find out the correction. Actually, first of all I want to find out the kinetic energy. After then I will using first order perturbation theory, I will correction that change. So I already prove the energy shift in case of hydrogen spectrum by using fine structure concept, but right now I derive the energy correction due to this alkali spectrum, because alkali spectrum there is need of energy correction. Why? Because alkali spectrum is in relativistic concept. So that's why we need some calculation, we need some corrections to this energy. So that is the reason I apply the same principle. After then I want to correction using the fine structure concept, hydrogen atom. Okay. So that is the theory. Right now I will consider, I will take common from here m naught c square, m naught c power 4 in both sides. See, total energy E is equal to, from this equation total energy, see take m naught c power square, take common outside. So this is equivalent to, see take m naught c square common, that is called, see p square c square by m naught square c power 4 plus 1 whole power 1 by 2. So simply take 1 by 2 means that is m naught c square, because there is a root. So you will take common out of root. So that is the reason. So minus m naught c square plus v. So after then this equation E is written as m naught c square. So simply take, this is 1 plus p square c square divided by m naught square c power 4 into 1 by 2. Okay. So minus m naught c square plus v. So using binomial expansion you can expand this equation. How you will expand binomially I will explain this equation. Is equal to m naught c square into, so 1 plus 1 by 2 into p square c square by m naught square c power 4 first term minus 1 by 8 into p square c square by m naught 4 c power 4. Okay, because m naught power 4 c naught power 4, by using this equation p square c square. Okay, sir, that is nothing but p power 4 andi, sorry, p power 4, okay. So once again I do mistake. So simply first of all take the cancellation here. So there is a p square here, c power 4 is there. So you will cut 2 times, you will get this equation into E is equal to m naught c square into 1 plus c. This is called p square by m naught square c square, okay, whole power 1 by 2 minus m naught c square plus v. Simply you will get, okay. After then see, I will do the calculations here. So therefore finally you will apply the binomial expansion to this term. So therefore E is equal to m naught c square root over 1 plus p square 1 by 2 times p square into m naught square c square minus 1 by 8 times of p power 4 divided by m power 4 c power 4, okay, plus so on. Don't take higher terms, only 3 is enough, minus m naught c square plus potential V. So simply expand this equation. This is called m naught c square plus 1 by p square by 2 m naught square c square into m naught c square minus 1 by 8 p power 4 divided by m naught power 4 c power 4 into m naught square c square, sorry, m naught c square, okay, minus m naught c square plus V. Say simply this term and this term will be cancelled, and finally you will get E is equal to p square by 2 into see m naught square m naught. So only one m naught is there, okay, 2 p square by 2 m naught plus you will write this potential V, okay. So close this thing, minus p power 4 divided by 8 into take 1 m naught cube and c, this is called c square, okay. So you will get finally this is the total energy in relativistic correction. So this is called relativistic energy, understand. So this is the relativistic energy. So see, compared due to Hamiltonian, so this is called total energy in quantum mechanics. Total energy Q is equal to h naught plus h dash, where h dash is called perturbed state, okay, and this is h naught is nothing but p square by 2m plus v. But this is called total kinetic energy plus potential energy, and this is gives total energy. So total energy of the oscillator is equal to total energy of the particle is equal to h naught plus h1. So this is called perturbed state. So I want to find out the correction by using unperturbed state. So this is called unperturbed state. This is called perturbed state. So perturbed state is no problem, it is equivalent, but unperturbed state h dash is equal to right now what is that, p power 4 minus p power 4 8 m naught square c square, m naught cube c square. So this is called energy correction shift. This is called energy correction shift. This is called energy correction shift. Okay, using this energy correction shift, I want to correction the above equation. So using this unperturbed state. Okay, so I want to take first order correction to solve this. So using first order correction, so take Hamiltonian unperturbed state h dash is equal to minus expectation p power 4 by c 8 m naught cube c square. So this is the first order correction theory. So due to this first order correction, okay, see, this is the first order. How I will take the first order correction. See, actually here P is nothing but expectation P, that is called momentum, that is called I into C. Actually P is equal to I H cross. I H cross delta. Okay, so this is the momentum in momentum in quantum mechanics. So that momentum P times 4 is nothing but I power 4 H cross 4 delta power 4. So this is called I plus, because I power 4 is nothing but plus H cross 4 into delta 4. So simply substitute. This is the expectation value. By using quantum mechanics, we will write expectation minus is equal to integral take minus 1 by 8 m naught cube c square into integral. See, take h cross, h is also constant, h cross 4. Simply substitute, this is h cross power 4 delta power 4 into psi star del power 4 into psi d2. So this is called expectation state. Okay. So using this expectation state, you will get direct, I will write relativistic energy, because it is a lot of mathematics. It will take a long time. So that's why in competitive mode, I'll write direct step. See here, I write this is the actually a relativistic energy. So this energy E is equal to, we can write this energy E is equal to energy in non-relativistic case minus, see, if you write in non-relativistic case. So first of all, electron is right now treated as relativistic case. Okay. So but what about in previous case, I will write in previously I write total energy is equal to non-relativistic energy plus this is the energy. What is that energy? That is called relativistic energy. So this is energy. So this is called correction energy. So we can write this is we can represent R minus P power 4 divided by 8 m naught cube c square. So this is the actual formation. Okay. So right now I already derived this equation from fine structure concept. Fine structure concept, I will get already E n r. So non-relativistic case, in fine structure theorem, hydrogen atom, that energy is relativistic energy. Right now, if atom is treated as a relativistic particle in alkali spectrum. So in alkali spectrum, we will get this addition term. Okay, this is extra term will come. So I want to write now correction. I want to correct this term. So finally, I got energy shift, both relativistic and non-relativistic cases. Combined equation I will derive from combined equation of non-relativistic and relativistic cases. So for that purpose, see, I do this first order correction by using Hamiltonian perturbation theory. So due to Hamiltonian perturbation theory, I can write directly this equation. This equation is delta E relativistic is equal to delta E relativistic is equal to RCH alpha square z power 4 by n cube L into L plus 1 L plus half. Okay, L into L plus 1 L plus half. Okay, so otherwise no need to write L plus 1 L plus half, because it is already proved in previous session. That's why simply take n cube into, so this value is 1 by 1 divided by L plus half j value. So this is called j minus 3 by 4n. So this is the term. Okay, so this is the finally we get, but by solving this equation, you will get this equation delta E relativistic is equal to RCH alpha square z power 4 n cube into 1 by j. Okay, so what is the j value? J is nothing but L plus half only. So take L plus half. So this is the equation. Final equation, we will get this equation. Okay. So right now, from relativistic and non-relativistic correction equation, I will write. Okay. So therefore, finally I derive the shift energy. See, finally I derive the shift energy. So I will get in case of non-relativistic, I will get this equation. In relativistic case, so total energy is equal to energy shift delta E is equal to delta E in non-relativistic plus delta E in relativistic. So non-relativistic, I will get one equation. In previous equation, I will write that equation. Delta E is equal to delta E. By using spin orbit interaction, you will get delta E is equal to RCH alpha square z power 4 by n cube L into L plus 1 L plus half. This is the relativistic shift. Okay, relativistic shift, non-relativistic shift, and you will get relativistic shift is nothing but RCH alpha square z power 4 into root over n by so. So you will get relativistic shift. I will write relativistic shift. What is the delta E for relativistic shift? We will get that equation RCH alpha square z power 4 by n cube into 1 divided by L plus half minus 3 by 4n. So this is the relativistic shift I will get. Okay. So this now actually don't get confusion, because in fine structure we will find energy shift by using fine structure concept of hydrogen atom is nothing but non-relativistic nature. This is a non-relativistic equation, energy shift. Okay, using alkali spectrum I find out relativistic energy. So this is the relativistic energy. So right now I want to substitute relativistic and non-relativistic equations both. Okay, so this is nothing but actually minus, because this is momentum is minus h cross, that's why it comes minus. So this is the minus equation. Okay, so this is the plus equation. So right now these two I will added here. Okay, adding this I will get one equation, that is called, see both are adding, I will add here. You will add both these equations, you will get complete correction of energy. Okay, so delta E is equal to, delta E non-relativistic case is RCH alpha square z power 4 divided by n cube into L plus 1 L plus half minus RCH alpha square z power 4 divided by n cube into 1 by L plus 1 L plus half minus 3 by 4n. Okay, so finally you will get this equation right now. Okay, right, take the common RCH alpha square z power 4 you will take common, divided by n cube is also take common. So you will get 1 by 2 into, why, because here there is a 2 I think. Okay, so 2 is there, I didn't write 2, 1 by 2. Okay, so after then this is nothing. Okay, so take 2 into L into 2L into L plus half, L plus 1. Okay, so L plus 1. So actually I will write this equation, this is not L actually, because energy shift I written wrong here. So 2n cube L plus 1 L plus half. So this is the relativistic energy. Okay, so this is non-relativistic, this is relativistic. So right now this is 2 into L plus 1 L plus half. Okay, see here also not L, only 2. So therefore minus 1 by L plus half, minus of minus plus 3 by 4n. Okay, so this is your final equation. Take LCM and everything you can solve by using solvation, you will get final equation is right now minus RC. So that relativistic energy delta E for J is equal to L minus half. So this value will gives RCH alpha square z power 4 by n cube into, you will get only J plus 1 by 2. So L plus 1 by 2 minus 3 by 4n only. Okay, so you will get finally the same equation you will get. So what he was explained means, in relativistic case and non-relativistic case he observed both the energies, but these two energy shifts are never equal. So therefore he think that some correction is added to this two states, you will get the same state. So in non-relativistic case, which equation is observed? The same equation we observed in relativistic case also. So that is the wonderful, because in relativistic energy what is the equation you will get, the same equation you will get from after adding the non-relativistic case also. After adding the non-relativistic case, you will get the same equation. So, if delta E is equal to J from L plus half, you will get same RCH alpha square Z power 4 by n cube into you will get 1 by J minus 1 by 2 minus 3 by 4n. Same equations you will get finally. Okay. Okay, understand everybody? So once again I just give a small small detail explanation this. First of all we find delta energy, shift energy non-relativistic case. Okay. So after that we find out energy in relativistic case. Okay. So here there is some modification identified by scientists. So therefore he introduced a correction to energy concept, correction energy concept. So due to this correction energy concept, so finally we will get relativistic energy. Okay. So this energy is addition of both cases, delta E non-relativistic plus delta E relativistic. So adding these both two, you will get the same equation what we are getting in relativistic energy. So the same energy will be once again he was considered. So you will get same equation. So this is called energy at J is equal to L plus half, L minus half case, and J is equal to L plus half case. So you will get these equations. So in minus half you will get minus, and plus half you will get plus only. Okay. So remaining is everything is equal. Okay. So sorry, this is L plus 1, this is L minus 1. So remaining everything. So these are the energy shift corrections in relativistic concept. So this is the energy shift equation. So this is called energy shift equations. Okay. So what are the term values of that equation? Term values represent delta T is equal to, so term value delta T is equal to delta E by CH only. So therefore that is called R alpha square Z power 4. R alpha square Z power 4 divided by n cube into L plus half 3 by 4n. Okay. So this is from J is equal to L plus half. Okay. You will get this equation from J is equal to half minus. Okay. So the term value delta T from J is equal to L plus half is equal to minus this value is nothing but this value. Okay. So this value is 5.84 centimeter inverse. So this is called 5.84 centimeter inverse divided by n cube into 1 by L plus half minus 3 by 4n. So you will get finally this is the term shift of shift equation. Okay. So this is about relativistic and non-relativistic case. In relativistic in relativistic case, the particle, the electron is treated as a relativistic particle. For that purpose we need some energy correction, because in relativistic correction the rest mass energy will be added to the system. So therefore according to the rest mass energy there is a one energy term, extra energy term will be arranged. That energy is nothing but H dash equal to minus P power 4 by 8 m naught cube C square. So this is the energy term is adding. So we want to need some energy correction. For that purpose further this experiment was expanded according to quantum theory of perturbation. Consider quantum theory, perturbation theory. By using perturbation theory, the unperturbed states will be considered. In unperturbed state, after the solving that equation you will get this equation. Okay. So after then adding of relativistic correction and non-relativistic energies both are adding. So finally you will get this is the energy shift terms of J is equal to L plus half, J is equal to N minus half. So you can use this equation for any state. Okay. You will get some I'll do some problem, one important application task by using this equation. So that will very helpful to finding out shift energy shifts. Okay. So this is actually concept. So tomorrow next concept I explain that term shifts. Okay. Thank you very much.